Hey folks, thanks for joining us here today. We have an entertaining session for you, a bunch of content. So we're gonna go pretty quick through this content with you, but there's gonna be Q&A at the end, so looking forward to get some of your questions. Feel free to, for those of you online as well, to be able to join through there. So we're going to be talking about AI everywhere today, and so let's get the right screen up here, AI everywhere, accelerate your development from PC to cloud. Looking forward to going through these details with you. I am Brian Rogers. I'm a solution architect at Intel.
I'm Brian Ehlert. I'm Director of Product Management at F5 for NGINX.
Lior Kamrat, Principal Program Manager lead in our Adaptive Cloud Approach program, OLAP.
Hey guys, I'm Koyanagi. I work on AI solutions at Intel.
Great to meet everybody today. So first thing we're going to talk about today is what's coming up on a CPU. Why does it matter for you folks? So on the Xeon platform with the AI, so that's why we're going from PC to cloud or cloud to PC. We're going to start in the cloud. AMX is really good for our matrix multiplications. So this is a place where AI is going to go and accelerate on the CPU. It's important that all of you, as a call to action, here's the thing to go do. If you're running on a Linux platform, this is a great way to go figure out if you have it on your platform. Just take a look. You're going to see those little red dots there, AMX on the bottom, BF16 and BF8. For those of you in AI, the data types do matter, right? And we know that there's a lot of data types that you select, and it's good to be on the AMX platform. Definitely is going to be focusing right now on that BF16 and the int8. So with that, what we're trying to do is figure out with you folks, what is the real world use cases that we're focused on right now? And efficiency is one of them, right? You know, there's tops and flops, of course, but bringing the right assets in the right place at the right time is very important. For example, with the AI PC, it's combining the power of all the 3 XPUs out there. So GPU, CPU, your NPUs, and you know what the future holds in front of us as well. And also security is very big for us. We want to make sure that we're focused on security, and this is where Intel can definitely help you have an AI workload that is secured in the cloud as well. Developer ready, so your AI PC, your off-the-shelf laptops, you can download PyTorch, get going with as a developer, and obviously with Windows SL. This is places where we really have worked with the community to get up and going. Hybrid AI as well. AI solutions just don't live in the cloud or the edge. They're comprised across all the areas that you know and love today. And Intel's there providing support with AVX512, PyTorch, DirectML, Web GPU, Transformer.js, and WebNN standards that we've all heard about already today. So we're excited to be there with you, and we're excited for your feedback as we grow in the community. And that's really important too. In the ecosystem, what you're going to hear here as we turn over to the next speaker, you're going to see that we are working across the ecosystem, make sure we're there for everybody, right? We're an open ecosystem partner. We like to play everywhere you are, and we do our best to get there. So again, AMX is just one of those, and I'll turn them over.
All right, thank you, Brian. So with NGINX, when organizations are moving to the cloud, we often see them struggle to bring their applications, whether that be moving infrastructure or whether that be migrating to managed services. The burden of operating and maintaining the infrastructure themselves is something they're always contending with. We all know that services are less about managing the infrastructure and more about giving you time to design, build, and do cool things for your customers. Everybody likes doing those things. We took this and used this as a motivation to work closely with Microsoft and build NGINX as a service. It's a unique infrastructure as a service offering. It's exclusive to Azure. It brings you our NGINX Plus enterprise product under the hood, and it also exclusively runs on Intel under the hood. NGINX, you might not realize, is almost 20 years old and is foundational to the internet that you experience today. It's been reliable, it's been fast, and there's a number of web properties out there that depend on NGINX every day to run their mission-critical applications, whether that be e-commerce, whether that be emergency services, whether that be financial, or whether that be even entertainment. NGINX began with solving the C10K problem. It was literally 10,000 concurrent connections for a web server. Relatively humble beginnings compared to what we think about today as we help customers architect websites and web servers and transactions that they're talking about in the tens, hundreds of thousands, and millions of transactions per second. You still might think of NGINX as either the open source project or the simple web server that it started from years ago. But NGINX can fill various roles. It can be a reverse proxy. It can be a load balancer. It can be an API gateway. It can be a cache server. And it can be a streaming server. And if you need programmability, there is NGINX JavaScript under the hood that lets customers build some really unique Layer 4 and Layer 7 experiences. Now, I keep mentioning NGINX. But when we talk about NGINX as a service, we're bringing you NGINX Plus, which is our enterprise-grade product. It is our paid offering. And it brings you clustering. It brings you state sharing. It brings you active health checks. And it brings you exclusive modules and even protocols. And it brings you over 200 metrics out of the box. Now, NGINX as a service has taken all this goodness from NGINX Plus, and it's fully operationalized it for you. So literally, all you do is you bring your configuration, and we do all the rest. It's a first-class service within Azure. It's jointly built with Microsoft, and it gives you all the interfaces you'd expect. So you've got SDK, CLI, Portal, Terraform, and even ARM. Those 200 metrics that I mentioned just a moment ago, you can access all of those through Azure Monitor. So you can see what the warm spots are within your application topology long before your alerting system might clue you off to a hotspot. Because we all know that when you're looking for blame, you need the knowledge in order to figure out where that lies. If you're a company that's worried about managing your secrets through Azure Key Vault, we'll give you a simple way to reference those secrets in your NGINX configuration so they remain obscure, and you can lifecycle them over in Key Vault, and we take care of all the rest on the NGINX as a service side. If you're operationally inclined, you might be interested in NGINX error or access logs, and you can access all those through Log Analytics. And for those customers of ours today that are asking for firewall integration, we're currently working on building integration with F5 NGINX App Protect Web Application Firewall. And you'll see that coming into preview shortly. And I don't want to leave out Azure Kubernetes Service, because we're building some unique value there. So not only will we support your services running in Azure Kubernetes Service, but we can help you build some multi-cluster, failover, and high availability use cases that are relatively unique to us. Getting and starting with NGINX as a service is relatively simple. You go to the Azure Marketplace, you search for NGINX, and you select NGINX as a service. We've got a basic plan, and we've got an enterprise plan with full SLAs there for you to get started. Now, AI is a big deal this week. I think that's kind of an understatement. And I think it would be kind of a miss if I didn't mention a little bit about AI. So NGINX is actually already part of a lot of AI infrastructures out there. Based on its reliability and flexibility, it's already worked into AI applications as well as SaaS services that are out in the community. You might have heard of the OpenVINO project toolkit from our friends here at Intel. NGINX is there under the hood. But in this example here, we're augmenting this with NGINX Plus to give high availability, those deep insights, active health checks, and even API protections. In this particular diagram, it shows an active-passive HA configuration. Now, say we take a little bit of NGINX Plus state sharing magic, and we can turn that into an active-active implementation, allow it to scale, and probably give you 1 more 9, maybe 2 of service availability, depending on how you model it. And if you happen to be working with Azure OpenAI, you can drop in NGINX to protect your training data, or to provide a high-value HTTP ingestion endpoint. And if you're doing an RAG style implementation, you might need to gate access based on user or other context that's coming in there. And NGINX can solve all these use cases for you. The open source project, as well as the NGINX Plus commercial product. As a service, we operationalize all that NGINX Plus goodness for you, whether it be a web server, whether it be a reverse proxy, whether it be a load balancer, cache, or streaming server. And we're all more efficient as we run it on top of Intel. And at that, I'll hand it off to Lior.
Thank you, sir. Hi, everyone. Good morning. I do better. Good morning. Thank you. I love to feel welcome, you know. All right. Hi, everyone. Thanks you, Intel, for having me in this conversation. I was actually kind of excited because, you know, recently when we started doing things, I was just kind of thinking about that session. I was thinking, how do we can actually complement the things that we're doing with Intel? So my friend here mentioned OpenVINO. I'll talk about that in a second here. But just kind of give you a bit of background of, you know, why do I even here talking to you? So part of what I do is, you know, here in Microsoft is looking at all the technologies that we have going on when it comes to edge and cloud, right? And how do we bring those technologies together? We call that adaptive cloud approach, which is something that we started communicating in previous Ignite last year. And when you think about something like adaptive cloud approach, shameless plug, that's on my shirt, I'm just saying, okay? I thought that was funny, by the way, that joke. All right, so when you think about adaptive cloud approach and what does that really mean? It starts with people. When we say adaptive cloud approach, we're talking about how do we actually bring people together that until that point were very siloed. So we think about developer audience, when you think about platform engineering, architects, IT ops, right? All these different groups inside an organization, a lot of the time what we found is that they're very siloed, and this is no surprise. I mean, all of you are working with this type of companies. A lot of you are experiencing this yourself. So when we're talking adaptive cloud, we're talking about how do we actually bring those groups together by using our technologies and actually making those stick together as a unit. So with that, I'm just gonna, one slide that we have that I wanted to show.
Sorry.
Yeah.
Go back to one.
He's my MC.
I'm trying,
you go.
folks.
All right.
There you go.
So I thought about a few examples of what does that really mean, adaptive cloud, and how does that actually come to life in the context of technology, and this session specifically, okay? So we talked about, you know, Brian mentioned use cases, okay, that they're looking at. So what are these use cases? Just to kind of connect this to the real world in context of, you know, AI, generative AI, RAGs models, like all this type of stuff. Like how does that actually come to real life? So what you see here is just an example to a queue checkout monitoring service, okay? And I'll show you that in a demo here in a second. What we're doing here, okay, in this evaluation experience that, again, we'll show it, is basically simulating a store, a supermarket, okay? And usually when you think about supermarket, the first thing that comes to mind is not AI, right? But if you start thinking about the use cases that are underneath, you know, something that is kind of legacy, like a supermarket, there's actually a lot of interesting stuff. Things like, you know, shoplifting is a big one. You know, queue monitoring and people density, posing, okay? What's the density in the shelves, like in terms of the store, the products? These type of use cases are real use cases. So what we wanted is to pick one of those and show how using different models, okay, actually help, okay? So that's the kind of high-level architecture that you see here. I'll switch here to my environment. And apologies, this is a recorded demo. Usually I like to do this type of live, but just because of, you know, the time element, and I want it to be on point. So I don't know why I'm apologizing this is a recorded demo. It's a recorded demo, okay? All right. Yeah. So what you see here is an example. So this is Contoso Supermarket, okay? And what they're trying to do is they're trying to understand, okay, how do we actually start looking, using AI, how do we actually start looking at people at the store and trying to understand, first of all, how many people are in the store, and then make some smart decisions around how many queues, how many checkouts do we need to open, okay, because of the people density. So I'm gonna just hit play here, and you're gonna see this thing come off. So what you see here is basically just a GitOps manifest or a Kubernetes manifest, right? What we're doing is we're basically deploying a model, okay, using OpenVINO. We're deploying a model at the store using GitOps, okay? Now, the thing here with the GitOps thing is that, honestly, it's in implementation detail, okay? Why am I saying it's in implementation detail? Because these clusters, okay, that are running at the store, those are Kubernetes clusters, okay, that are Arc-enabled, okay? Because they are Arc-enabled, right, we're able to deploy GitOps configurations on top of those clusters. Now, don't think about just one store. Think about a fleet of stores, okay, that you can go and deploy these type of models, you know, at scale in all the stores. So what you see here under the hood is you're seeing basically OpenVINO that is looking at the people, like I mentioned, the people proximity. So this is just one of the models, okay, that we have going on. So this is one example of something that we do with Intel, okay? So just kind of give you a bit of the art of the possible. Now, the second thing that I want to show you is a project that we have, which is now turned into a product. That's the Arc Jumpstart, okay? In the Arc Jumpstart, which is kind of how you get started with things, okay? We have something called Jumpstart Agora. And Agora is basically a marketplace for industry-related scenario. You'll hear that a lot, you know, in the next coming days and, you know, future events. Like industries is something that we're starting to focus on heavily in the context of AI, just to make sure that we are hitting the right points, which is what I showed you right now, right? We took a very legit use case and I showed you how does that can look like in the store using an AI model, right? So what we did and what I just showed you is actually part of Agora. So if you go to the retail scenario, you will be able to deploy yourself that Contoso supermarket setup. Just evaluate that, okay, in a sandbox environment. And this week, we also released the manufacturing scenario. So let me just kind of show you what we have here. So the manufacturing scenario, and I'll try to zoom in here. I hope everyone can see it okay. That's okay for the folks on the back? Yeah? All right. So what you see here is basically the technology stack for Contoso Motors. Okay, we talked about Contoso Supermarket, but Contoso Motors, they also have a lot of use cases that's got to do with AI, or how you can use AI in order to leverage those, in order to solve these type of use cases for Contoso Motors. So you can see there on the top, you can see things like welding and pose estimation and helmet detection, worker safety, you know, stuff like that. So in this case, what we're doing also with Intel is we're actually using OVMS, which is the model server that is deployed on top of Kubernetes, okay, in order to deploy multiple models like YOLO and a bunch of others, in order to achieve these type of use cases, or in order for us to solve for these type of use cases that you see there on the top. Just going to show you an example here. Let me just scroll here just a bit and show you this one. So there you go. So what you see here is basically a full-blown environment, and we have a Kubernetes cluster that is deployed at the factory floor, okay? And on that cluster, we actually have OpenVINO. That's the model server. That's the operator, the Kubernetes operator that allows you to deploy these models at scale, okay? Now, one of these models, okay, is able to actually do welding detection, where there is welding, what's the temperature of the welding, stuff like that. So these are just kind of examples of how to go about this, okay? And again, this is really fast talk and just the art of the possible. There's actually a session that we're going to go a lot deeper tomorrow on all these use cases and a lot more, trust me. So there is that. And again, how to get started, arcjumpstart.com. You have all of this stuff over there, how you can actually deploy all things in a sandbox fashion, easy one-click deployment. Peace. Thank you so much.
Thank you, Lior.
Okay.
Thanks, Lior.
Yep. I got claps.
Thank you. OK, everyone. So now I'm going to shift over to more of the edge side. So I'm going to talk about how to use ONNX Runtime with DirectML EP and ONNX Runtime Execution Provider for your generative AI use cases on PC. And I promise I just have 2 slides, and then I'll get into a demo. So first, today we're at this inflection point where we have an opportunity where we have generative AI usages. The models are quite capable, right, in what they're able to do. And now we have this AI PC. So we're at this point where we've been shaping the AI experience with Microsoft to bring this AI PC. And what this is we have the CPU, GPU, and neural processing unit. I'll just refer to it as NPU throughout the session. So hopefully that's OK. And so now the next question is, how can we start using these engines today? So we'll focus on ONNX Runtime as the runtime for today. And to be able to use this, I'll go over through the diagram here. So on the left-hand side, we have what may be your application. So you have your pre-trained ONNX model on the left, and then you have some kind of input data. And then we'll call into the ONNX Runtime API, and through that, we have these extensions that help accelerate your use case for the specific hardware you have. And the two I'll focus on today, once again, is DirectML and OpenVINO, which you'll see here in green. And this is what we'll use to target not only CPU, but GPU and NPU today. So lastly, I do also want to mention for the Python developers here, you can install these ONNX runtime builds that come along with the execution providers through the pip installs you'll see below. OK. With that, as promised, we'll go straight into the demo. OK. So the first part I want to go through is just using ONNX runtime. And you may be familiar with the normal ONNX runtime APIs, and I will be using Python today. So the first thing we'll do is we'll import ONNX runtime here and then get the library. But the thing we're going to check here now is what execution providers are available. So run this cell, and what you see here, it's returning OpenVINO and DML as EPs. So if you go through the pip install, you will be able to get these execution providers available to you. But actually, what I've done here today is I've compiled ONNX runtime through source with both OpenVINO and DirectML as the build options. OK, so the next thing I want to do, let's say I'm on this system, right? And I want to see, using OpenVINO EP, what kind of devices will I have available? So what kind of hardware will I see? I'll be able to see all three here. So I have the CPU, GPU, and NPU devices accessible to me. And then the next, it's fairly standard. So you have the inference session that you'll create. And in this instance, I actually want to use OpenVINO as the execution provider. So I will list it here under providers. So I'll target OpenVINO. And then underneath it, let's say now I want to use NPU. So I'll select that as the device type. And then one other option I'll provide is the cache directory. So it's a good idea in most cases just to cache your compiled model. So I'll include that here. So now that session is instantiated, it's ready. And just to show the functionality of this, typically you'll have some kind of more meaningful data. But for right now, I just have some kind of random tensors going in. So I'll run that with session.run. And I'll have an output here. So this is just showing what you could do with ONNX runtime and how to target and use your execution providers. But since this session is about generative AI, I have two demos next. So the first one will be small language model, and then the second one will be for image generation. So I'll go to the first one. OK, so the first one I have to show you is with the small language model by Microsoft. It's Phi-3. I'm using the mini version. And this is open source. It's available today. You can grab it from somewhere like Hugging Face or also Azure AI Model Catalog. So today, I've already downloaded the model. So I have it ready. And we'll load the model here. And what you can see here, I actually am using Optimum as a library. And why I'm doing that is it does have ONNX runtime as the runtime available. And it makes everything really easy. So if you don't want to worry too much about your pipelining, session management, and all of the inputs that are from the model, this makes it really easy. So the first thing we want to do, now that we have this downloaded model, right, we will point it to the directory, give it the file name for that model. So since this is for ONNX runtime, we are using the pre-trained ONNX model. And then the most notable portions here is the provider. So in this instance, we'll go with DirectML. And then additionally, we'll use GPU as the device type. So I did already load this. And the only thing after you would need to do, actually, also, the tokenizer is loaded as well. Now, after that, we can give it some kind of prompt. So I have this prompt here. It says, I should feed my dog. And we'll tokenize it. So now we have the word embeddings. And then all we need to do is generate the results. So what this is doing is it's using DML and GPU to produce some kind of output from the prompt. And it says I should feed my dog twice a day. Absolutely, feeding your dog twice a day is generally recommended. And then it has other text. I don't own a dog, so I can't verify if that's correct, but it sounds like a good thing. OK, so that's DirectML and how to use it. The second one I have here is the latency consistency model. And in this one, I'll use OpenVINO EP as the execution provider. And let's say we want to generate some high-quality images, and we want to do it fairly quickly. So this is the next step from like latent diffusion model. So we should be able to generate images in just a few steps. So anywhere from, say, 1 to 4 steps is sufficient. But we'll use 4 steps today. And once again, you can download this model from Hugging Face. OK, so continuing on with the API, we will use Optimum again. And then same steps. So we do point it to the directory where the pre-trained model is. And then the only change here, now we're going to use the OpenVINO execution provider. Select the device type as GPU again, and then give it a cache directory, because we only want to compile the model once. So I've already initialized that. And then I do have a prompt here, camping under the night sky. And actually, I haven't ran this yet, so I don't know what kind of results it'll give, because it's always fun to see what happens. And just talking through this, so I am running this for 4 inference steps in this session. And then we do give it a guidance scale of 8, so somewhere in the middle in terms of how creative to be with the prompt. And then it's generating a 512 by 512 image. And as you can see here, it runs fairly quickly. This looks like a pretty good image, but just in case, let's run it one more time. I think this one's also good. So yeah, so this is how to use OpenVINO EP alongside ONNX Runtime. And with that, I think we could open up to questions.
Yeah, so folks, the one thing I want to do right before questions is just say thanks for everybody coming here, for you folks presenting on behalf of Intel and talking through this today. As you can tell, what you're seeing from Intel is that we're really across the board. I like to say sometimes, if you think about the Wizard of Oz, anybody see the Wizard of Oz? Come on, yeah, a couple hands, all right. You know, the man behind the curtain, he might be small, but we're there in some of these places. So we do a lot of software. We get in there to make sure that the software runs best on our architectures, and that's kind of what you're seeing. And the other focus that we've had over the years is, again, how to be best in the community with you. So we do a lot of open source, and if you hear Kubernetes, we're a big contributor to Kubernetes. We do a lot of upstreaming there as well. We're one of the larger contributors to Linux on that side of Linux kernels. These are all places that we want to make sure that those platforms, the platforms that you folks use to do your daily business, is running best on Intel. So thank you for coming, and we'll start opening up to a few questions. Do we have any coming through by any chance?
Yeah, Brian, a couple questions online. What software currently supports AMX?
That's a great question. So some of the ones that I open up with currently support AMX. So that's what you're seeing is PyTorch. You're seeing OpenVINO. It's going to support AMX. So the good news is, like the demo that Lior gave, running that on a Xeon with AMX instruction sets, you will get a lot of that natively, right? There would be very few code changes. There would be a couple lines here and there to import the right libraries, but you'll be ready to go. So we're excited to be doing that with the community. And we're excited to be working with you folks, you know, kind of across the board on how we're bringing these type of general things, whether it's PyTorch, TensorFlow. Again, the Transformer.js is another place we've integrated with, as well as WebGPU and WebNN, all places that Intel's made sure that we are there to support your architectures and your projects.
Okay, we got another one. Will there be any additional security for AMX?
Who cares about security in here? Throw it out the door? Nobody cares? Come on, yeah, right? Nobody wants security. I hate security. No, just joking. I love security, actually. It's a big background for me. So the thing with security is there's a lot of platforms coming up. So we've done 2 of the big ones, and obviously the third one is what we'll talk about most specifically. But the 2 big ones was data in flight. We all know what that was, right? We did the SSL. OpenSSL was one of the groups that we've worked with. Anything TLS, so on and so forth. We know that there's changes coming into that too with post-quantum. So just to remind everybody, with post-quantum cryptography, that's a place that we're going to be looking to play with some of our partners to make sure that in post-quantum world, we're dealing with security in flight, in transit. Another one was at rest, right? So that's another place that Intel does a lot. We have the, like Intel, our quick assist technologies with QAT. So if you're running on-prem, you see QAT on your boxes, take advantage of that. There's a lot of encoding and compression and encryption that we're doing there to help you folks out. But the one that's most important today, when we're talking about this type of AI scenario, like Lior went through and Brian went through, and also what Ken said was, we got to go focus on how to secure our AI models. And that's both from the cloud to the client and everything in between. So what we were looking for is memory at runtime. You know, obviously there's a few options in market. Intel also has some. We had SGX was first mover on that. SGX is a great place to make sure that you look at. It is a heavy lift, but there's a lot of things out there. So if you're not faint of heart, take a look at SGX, right? But SGX is going to give you a lot of programmability all the way down to the application memory level and saying this application is running securely no matter what. The world can blow up around it and that application is going to be safe. And then the next level is TDX. So being able to encrypt the VM. To have your TEE setting up as a VM is very important. So these are places that we'll be working across the board to make sure that security is in place for you folks to leverage this. And then all the way down in the future, we'll be looking at, you know, how we get down to the desktop with that. There is another technology, a little used one called TME, which is also memory at rest. So if you want your memory at rest, it gives you an extra valid thing, value for having security at that point. So those are some of the places we're going to do security. Does anybody think about, how does everybody think about the cloud right now? I mean, we know that we've gone into this big thing. Does anybody know mainframes? Anybody been a mainframe developer? You're probably going to answer the question for me. Does this seem like a mainframe when we moved everything to one big area, right? And then what's the next thing we're going to do? Split it back out, right? Guess what's happening next? We're going to split it back out, AI PC, right? So these are the places where security is going to become so important, right? And we're going to really be working across the communities to help you do that. There's a couple reasons for that. One, this is one that you probably don't think about often, is when we move this and split this out, what is this giving us when we go to these big data centers? I was just on a call the other day. Scalability. On a call the other day, 15 megawatts, which isn't a lot for a data center, but it's a decent sized data center, not available globally. Right? People are having hard times getting that much power. I'm not joking. So we're now at a point where power is limiting us. We thought it was space, we thought it was this, we thought it was that, now it's power. So where do you get power? I got power right here. I got power right there. I got power right there. This is how we're going to continue to scale. That's where AI PC is really going to go in place. And that's also why we're so focused on helping secure these pipelines with you folks. So make sure that you're looking at these things. So the other thing to look at with security would be AVX512 underneath that. Why? It helps you offload some of the instructions from the CPU itself. So as you're looking at your cycles, right, offloading with AVX512 brings it into another part of the SoC kind of chipset. So you still get to use and leverage your CPU at like 75% right, utilization, but you can offload calls with AVX512 in another place. So you're getting like double value in those places. AMX is one of those things, and that's why we're bringing it for you today. I know we were a little bit light in the beginning, but AMX is another place where we're going to be able to offload the CPU. So if you're doing inferencing on the front, it's a good place to be so you can continue to run those workloads and scale, right, and have less costs, right, for your AI inferencing. Next question.
That's all we had online.
That's all we have online. Well, we got a couple minutes left. Lior, do you have any impromptu you want to do? He said he's getting more claps than me. Can I get at least one clap, just one? I said mainframes, right? I mean, come on. Right, see, I got some claps.
Challenge accepted. No, I think that, you know, when you look at this type of stuff, right, and when you're trying to connect it to this industry conversation that we were having, these are legit things, you know. These are real things that solves real problem. Maybe not, well, I guess how many times you need to feed your dog. But if you think about it, even something like small, or not small, but simple use case like this, if you think about companies that are, creating this type of auto-feeding machine, right? I have a golden retriever. He eats a lot. I don't use a machine. But if you think about this type of models, these are the things that these companies can use in order to learn the behavior, right? Because it's all about the trend. It's all about the behavior. It's all about how to make things more efficient, right? Talking about power consumption and all this type of stuff. So if you ask me, like in terms of how do I look at this from the things that me and my team are doing, I'm thinking about this type of use cases, right? I'm thinking about how do I solve problems for large retailers? How do I solve problems for manufacturers that are living in an OT space that is, generally speaking, very legacy space, right? How do I actually go about and do that? And the use cases are endless. Healthcare, finance, fintech, like there's so many. And I don't know. I just hope that I'll be around to enjoy all of this stuff, because this is I think that this is really endless.
You're gonna be around.
I'll try.
Yeah, no, it's for sure, because we're doing more today with it. And so that's actually, you brought up fintech, and actually the healthcare was really interesting. There's a lot going on in healthcare too, so let's talk about that. So like the demo that you gave today, we're putting things together, we're using videos. Well, healthcare is just as important, right? So it's video, or right now it's imaging. We're gonna be taking imaging. Yeah. But video is coming. We're looking at ultrasounds, we're looking at other data. Why is this important? Well, additionally, to train more models, federated learning. This is a place, so it's like, I think sometimes we sit up here and we forget, hey, where's the hello world in all this? How do we get started, right? What's the basic stuff? And this comes down to your data. How do we start classification of your data? How do we make sure your data is clean? How do we make sure that we're going good and moving forward? These are things where AI and data, right? We kind of left over that for a few years now. Like we've been really focused. We got the model up. We're really excited about it, but we still need the data. Even more, we need to share that data. Why do we want to share the data? Well, I don't want to share my sensitive information. It's mine. You're right. Keep your sensitive information. Federated learning is where you want to come in with that. So looking at federated learning, we're able to now train models in remote data sets, and we did this demo last year in Build as well. So take a look at the 2023, also on our website. But there is a lot that you can do now where you can train these models and use other people's data. HIPAA compliant? Yes. Other type of compliances? Yes, we have that. So now you're running a retailer. Maybe you have a partner that's also a retailer. You want to share that data, but you don't want to actually share the data because that's PII or something that's unique to you. But you can at least let the model train, get smarter, and now everybody is getting a more enriched experience. And this is what we're looking to do with healthcare. We are going to see this in our lifetime. We're seeing it in genomics as well. So biotech is another place that we're seeing it. We want to help you folks, our hands, our feet on the ground, make sure that we have a future that's really bright. And then we're using AI sensibly, right? That's also kind of scary. But we want to use AI sensibly. And that's what we're helping promote too. Any questions come in while I was talking? No?
NPUs manufactured by Intel? The NPUs are manufactured by Intel, the ones that were presented in the keynote?
Repeat the question.
Yeah, so the question was, are the NPUs manufactured by Intel? And I believe that those are. Ken?
Yes. They're designed by Intel.
Designed by Intel. And we are, I don't know if you folks have heard, but we are also going into full fab level, right? So we are now open to bringing your ideas into our fab and helping you modify and make your own chips. So that's also the future. Anybody else? Okay, one last thing I'm going to say. I touched on it before, storage. So we're seeing things at the edge, right? More storage at the edge. I got into a conversation with a nuclear power plant once. Has anybody touched nuclear? Yeah, you guys keep me honest then, right? So nuclear was interesting because they dealt with every problem in the cost of life, right? How many lives will this cost us? Does a door close or does the door stay open during an event? And what's the event? Guess what? The first thing they told me is you can't go to the cloud, right, for that event. You got to stay local. You got to stay on premise. These things that we're talking about here, the AI PC or the combination of being able how that allows us to have models down on the ground at a security level. It could, get us to the point that we can now start answering these questions. Should the door be closed or open, right, during a critical event? How many lives is this going to impact? It was a very interesting conversation during that to kind of hear how they remodeled the space and just saying, I can't have connectivity because in an all-out failure, I have no connectivity. So it's not just scaling out. It's also how do we secure when we've come to the point where we've lost connectivity and we have to have these machines thinking on their own. So that's another place that we're focused on today. All right. No other questions? Thank you all for coming. This has been a great event.
Thank you.
Thank you, everyone.
Catch Lior's stuff later. Thank you.